Okay, Assalamualaikum warahmatullahi wabarakatuh to Dr. Jeff. I am Akila Zani and these are my group members, Syed Muhammad Naufal, Syaira Sofian, Sini Yiling and Yashwini. So this is our discussion video and we're going to share our finding about the genes that the design primer for our chosen gene. So anyone to start first?
I'll start first.
All right.
Okay, Yiling.
Okay, so I found this gene from Texas brevifolia, 10 diacylbetaine 310O acetyl transferase mRNA. Okay, so this gene is from the Texas we were supposed to find from. Then I managed to get a very nice forward primer, which is from 19 base pair with the TM of 57.01 degrees Celsius and the CG content of 47 and 47.37%. But for the reverse primer, the CG content is a bit lacking, so I modified the primer by adding the C and G bases to the 5' in to make up the 45% of the CG content. So total length of the primer after adding the CG bases is 20 base pair. I added 4 CG bases, so I took 16 base pair from the full length of the cDNA. Then I added that 4 base pair, so makes up 20, and the TM is like 58 degrees Celsius, and the CG content is 45%, which is the optimum percentage. And both of these primer, they have the CG clamp at the 3' in, so it can bind really well. Yep, that's all from me.
All right, thanks, Yiling. I think next I'll proceed with my findings. All right, so the gene that I've chosen is texadiene synthase from Texas brevifolia as well. So for forward primer, my TM is 52 degrees Celsius. My TA is 47 degrees Celsius. My primal length is 17 nucleotides. I took 14 bases from the full length sequence and I add 3 at the 5' end to make it optimum. My GC content is 53%. And for forward primer, I have a GC clamp with 2 Cs at the 3' end. All right. And for my reverse primer, the TM is 58 degrees Celsius. TA is 53 degrees Celsius. Primal length is 19 nucleotides, which I took 13 nucleotides from the full length sequence. And I've added 6 bases, CG bases at the 5' end as well, same like the forward primer. So my GC content for reverse primer is 53%. And for my reverse primer, there isn't any GC clamp. I think maybe I need to modify a bit, and I think I'll update my modification or anything in WhatsApp group. So that is all from me.
Okay, I will go next. Since we know we always share our updates in our WhatsApp group, right? So since Yiling and Yash have updated us about those 2 genes, so we will find another gene from Texas brevifolia. We supposedly to find them, but since we cannot able to find any other genes from those species, so I found one, but from Texas cuspidata, means another species of Texas. So the best primer that I could design from this gene is from gene bank extensions of this family, which is 20 nucleotide length for both primers. The GC content for forward primers is 50%, while 45% for reverse primer. The TM for forward is 56.5 and 54.8 for reverse. That means the difference between both primers TM not more than 5 degrees Celsius. And there are no GC clamp for both primers. As we know, the GC clamp will be happen if the last 4 nucleotides have more than 2 G or C nucleotides, right? So for my forward primer, just have 2 G from 4 last nucleotide and just 1 G for my reverse primer. So it is stable primer. But as I mentioned before, it is not from Texas brevifolia. It is from Texas cuspidata. Since I'm not able to find any other gene from this species. So how about you guys?
Okay, okay. I will brief about my design primer on my gene. My gene is about my primer I designed from the gene Texas cuspidata bacatin aminophenylpropanil 13 O transferase. It's too long, sorry. Okay. But this gene is not from Texas brevifolia. It's from the Texas cuspidata. Okay. For this primer, the length is 22 for both primer and reverse primer, and okay, the TM is 54.8. Sorry, 54.18 for forward primer and 54.68 for reverse primer. And the GC content is both 45. For the, actually I a bit confused. The GC clamp is about the N3, right?
The 3' end.
The 3' M.
The primer, the last polynucleotide.
The,
Must be G or C, I think.
so kalau so if I have only C on the last, this means I have a one GC clamp, right?
Okay, wait.
From the last polynucleotides, it should not be more than 2G or C content.
Oh, okay. So this means I have a GC clamp, and yeah, that's all from me. But here I have some confused about the self complementary and GC clamp. Do you guys perasaan bahasa Inggeris apa? Do you guys notice? Do you guys notice? So, it has self complementary. I have confused. Is it self complementary have a meaning for the design primer?
I'm not sure.
Because I heard someone has said if the lowest self complementary is better for the design primer.
I think they said me, but actually for my primers, I haven't go through the self-complementary and so on.
Yeah,
So I'm not
same.
really.
Okay, that's all.
I think we can update on WhatsApp as how we used to do.
Okay.
Alright. So for my gene, my finding is also for Texas cuspidata. And my first primer is 20 base pair, forward primer. The TM is 55.99 and the GC content is 45%. And for my reverse primer is 17 base pair initially, but I have to add another 4 base pair to increase the GC content. So for my reverse primer is the temperature is 58.78 and my GC content is 47.62%. So the final base pair is 21. Both my primer doesn't have GC clamp. So yeah, that's it from me. So
I just want to confirm with you guys. GC clamp just happens when the G or C nucleotide on the last 4 at the end of the primer is higher than 2, right? So then there will be GC clamp, right?
yes.
So if there is this GC clamp, that's when our primer is not stable. Am I right?
I thought it's good having CG clamp.
GC clamp is
Yeah,
good.
I think
It make your primer
stable.
stickier, I think. Stickier.
Make it stable.
Yeah, at the same time end.
So it means
So
that
is
we
it
need to
better
have.
to have GC clamp or no?
Yes, better to
Better, right?
have.
It is better to have.
It's better to have, but then I think we shouldn't have more than 3.
Yeah,
Which
sure.
might
Like 1 or 2 is okay.
yeah.
Okay. Alright, so based on what we're sharing just now, I think we just able to found 2 genes from Texas brevifolia, right?
Yeah.
Yes.
Mhm.
It's
And the other
alright.
is from Texas cuspidata. So,
So how so we choose first the Yash and Yiling gene first,
uh-huh.
and
We
we
need how
And
much?
we're
decide
gonna
Jin?
keep
three
mhm,
3 genes.
3, right? So
Yeah.
how about the
3 genes,
another
yeah.
one?
We need to keep finding and update in our WhatsApp group, I
Oh
guess.
yeah.
Since this is our first discussion with you, right? So we just
Yeah.
need to share what we get.
Yeah.
So any questions?
No.
No.
But
Yes,
uh,
Kai.
No, but apa? No, but what?
yeah, I a bit confused. Okay, for this video, we discuss about this gene, right? What are we found on the gene, what type of gene, and so on. And then the next video, we need to talk about what? We need to discuss again about this or continue our discussion onward.
I think only
I
one
think there is
video.
no other
Yeah,
video, right?
no
Yeah,
other
No,
one
the
video.
video
video.
is sufficient.
Okay, I confused tengok Agila.
No, sorry. This
No,
is just our
after
discussion video, and
after
we're
this we
gonna proceed
update the
with the report.
WhatsApp.
Okay.
Yeah.
And then we can proceed with our report lah, right?
Yeah.
Mm-mm.
Yes.
But we still need to find another one gene from Texas brevifolia.
Yeah, if we cannot find, we just use the genes of other
Texas,
Texas.
Yeah. So that's all from us, I guess.
Yes.
Yep.
Okay.
Right,
Thank you,
doctor.
everyone.
Right.
All right. Thank you. Bye.